or I don't know what it is. Yep, I'm recording. Thank you. But there's been some issues with turning stuff in. So I just want to, not that, there we go. I want to review how we do that, okay? And for some of you, it might not be a review, and for some of you, it might be an honest issue where I don't have you logged in a certain site yet because I'm still getting used to having students added, which isn't a problem. I'm just getting better at getting everybody in where they need to go. Okay, so let's say that you have completed today's assignment, which is simplest radical form. Okay, the lesson is here. It's right in front there for you. There's lots of stuff. This is what you want to really learn it from. The live sessions are like extra practice, extra help, places to ask questions, places just to hear it again. There's examples, there's a video, and then now here is the assignment. You would go to Math Excel for School to help you do the assignment, okay? No, not that. I'm gonna go to homework and test, and then I'm gonna find the same assignment. Here it's called simplest radical form. I will tell you, some of the numbering may be off. I am trying to fix that, but I got a lot of stuff to do, so it's a little bit lower on my list, I'll be honest. But like the number might be off. Like I think this one is 2.08 and this one's 2.09. Doesn't matter. It's mainly the name. Simplest radical form. You're going to click on that and you're going to do it. Okay? Question 1. See what I get. Watch I get it wrong in front of everybody. Oh my gosh. Okay. List the first 6 positive integers that are perfect squares. We're going to talk about that today. Okay. Which ones are the perfect squares? We're going to go over this. I'm just kind of asking. What do you guys think? Oh, someone says A. Yeah, I totally agree with that. Very good. Definitely going to be A because 1 squared is 1. 2 squared is 4. I almost said 2. 3 squared is 9. 4 squared is 16. Yeah, definitely A. Good job. And if you did not know that, don't feel bad. We're going to go through it today. So then we're going to hit final check. Sweet. We got it right. Next question. But let's say you're like, oh my gosh, I don't get the rest of this assignment. I'm just going to hand it in. I don't recommend doing that, okay, by the way. You have to hit save up in this corner here, okay? Guys, find the save button. It's right in the upper right-hand corner. Click save. Oh yeah, use the examples, Aiden. That's a good point. Go to question help. Look at all these things that can help you. You can do help me solve this. It walks you through the problem, but then it will give you a different one at the end. You can do view an example. You can look at your textbook, although I don't think that's set up right. Yeah, I don't know what the issue is. I'm going to email Jim about that today because I've been having issues with that. And then you can go to ask my instructor, and that sends me an email of the question. And I know I got one, I think, yesterday, so today I will sit. And is that yours, Annabelle? Okay, yeah, definitely. So today, right after the live lesson, that's when I usually go through and do those. So I will send that back today. So there's lots of help there. But let's say you're like, meh, I've had it, I'm done. Hit save. And then this part on top here is what I need. You're going to highlight the whole thing, hit Control C, or just right click and go down to copy. Go back into Moodle, all the way down. Hit attempt quiz now. Sometimes you will have additional questions to answer in Moodle, but this one looks like not the case. Then we're going to hit Control V, and there's our score. And then we're going to hit finish attempt. And then you have to hit submit all and finish. I have had issues where people are turning in scores that don't match with what's in Math Excel. We gotta be really careful about that because it's not accurate. I've had some students who have entered in 100, and then I go into Math Excel and it looks like they haven't even done it yet. And I'm not saying that's like a dishonesty thing, because I don't think anybody would do that here. I just don't. Because this school's awesome. And yeah, nobody would be naughty if they get to go to school in their pajamas next to their pets, right? Right? That's what Princess Peach says next to me. She's over there. Wait, that's not her. That's my Chips. She. Okay, she is there. Do you guys see her? I don't know. She's there. It's hard to see. So, but yeah. So please make sure that you're hitting save, because if you're not, then that could be what's happening. Either someone's not hitting save or you're doing the wrong assignment. There's lots of reasons. If you need help, let me know. I'll meet with you and we can do it together. So, yeah. Any questions? Nope. All right. Thanks for saying nope. I like when people answer my questions. It's amazing. Okay, this is what's due this week. Thank you guys who are writing in chat. That's so helpful. You do have a STAR test to do. If you did the STAR test in orientation, then you don't have to do another one. All you got to do is just write done in orientation. That's me just making sure everybody has a result. Okay, let's talk about what do we do if we're so confused? Like, what if you're freaking out, you're behind? What do you guys think you should do?
Email you.
Yes! Email me, let me know, tell me, say, hey, I'm freaking out, super confused. I will find time where we can meet, because that's the best way to go through it. I worked with someone in the other class and we cranked through 2 assignments and he just felt so much better. He did. So, yeah. All right. So, stop texting me. Okay. So that is all I have for you right now. Let us go ahead and take a little break until 11:30. Yeah. So it's about 6 minutes, whatever. If it has to be 11:35, that's okay too. Go ahead and turn your camera off, chillax, go to the bathroom, get a snack, whatever you have to do. Okay? During this time, I highly recommend writing what is due this week in your assignment notebook or your planner, if you were given one. That is on the screen there. So I'm going to pause our recording. Let us resume our recordage and get crack-a-lackin'. Okay, friends and neighbors. So last week, oh, that's okay. Anthony, how's it going? How are y'all? How's it going?
You can say hi to class.
There's Annabelle. Okay. All right. Okay, so we're going to get started. I'm going to throw a little poll out there just to double check who's with me, who's ready to get going. Oh, I thought I had it. Okay, never mind. Are we ready to rock and roll? Okay. That's my question. Okay, that is saved. So I'm going to launch the polling. Are we ready to rock and roll? Get our math done? I got most of you've answered. Yay! Just waiting on 2 more voters.
She's so calm.
Oh, is that your kitten?
Yeah, this is my baby.
Hi, baby. Oh,
She's
she's
not really a kitten anymore. She's like 2, 3 years old.
That's a big kitty.
She's very fat. She's very, very fat. I can barely carry her up the stairs anymore.
My kitten is wrestling me right now. Here, get over here. Bite me. Don't bite me. No.
Oh, she gave me a kiss.
I was trying to get her to come say hi, but she just wanted to bite me. So she's at the end of the bed cleaning her
This is not
toes.
for you.
Oh, see, that's not. Oh, that's the wrong way I'm showing. There we go. There she is.
Aww.
Hunting birds.
Cute.
Couldn't find my glasses.
Oh, that's okay. You need that. Oh, the other glasses. Next time. That's okay. Picture, send it my way. It's all good. Okay, friends. We're going to get started. And yeah, so let's start talking about scientific notation. This was a topic from last week. I just want to make sure that we're good to go about it. Scientific notation is just another way to represent a number, okay? So if you have a number, remember the goal is to get that big, long number into a short condensed notation. So we make it so there's a whole number in front. Could have a decimal, but it's got to have a single digit number before that decimal sign. That is the goal there. And we're going to just review how that went. How did you guys feel about the assignments last week? Were you confused about scientific notation, about multiplying with scientific notation, or dividing? What would be a good one? It was easy? Okay.
It was pretty simple once I got the hang of it.
Sure. Cool, no problem. So, oh, it was the easiest. Okay, cool. Now, I would like to know, maybe I'll create a quick poll. That's what I'll do. Yeah. Edit poll. Add a question in there. Okay, my goodness. I have too many things open. Okay. Add. There we go. Okay, so my question here is going to be, what should we review from last week? Just in case you're like, it wasn't super easy for me. That is my idea there. So scientific notation, multiplying with scientific notation, or divide. No. Edit. I'm not done. There we go. Or dividing with, or no review, new stuff, please. That is what we will do. And that's what I usually do whenever there's a week where we don't have a live session. Okay, so I'm going to send that poll out to you guys. There we go. If you could answer honestly, that would be most appreciated. And just remember, just because everybody is saying, man, I got it, it's easy, you know, if you don't feel that way, that's fine. That's okay. Answer honestly. Because when I say I'll review it, I'll go through it quickly.
My cat's sleeping upstairs.
Aww, that's super cute. I love the kitties. Love those kitties. I'm still waiting on 2 people. Now, I will say if you are a new person in class, you don't have to worry. Oh, your mom found them? Let me see. Those are awesome. Those are so cool. Oh my gosh. Look at Ben's glasses, guys. Those are neat. He's going to start a trend. I love it. I will say that if you were new last week, or like you just joined this week, do I have anybody like that? Do I have a new person in here? I thought I did. I could be wrong. Logging in to Power School. Let's see. Oh yeah, you don't want to get a headache. That's not fun. Okay. Anthony, when did you join? Anthony, it probably says that on there. Okay, is this your first week, Anthony? All right, well, I thought so. Welcome, welcome, welcome. You know how I'm asking this poll about scientific notation? If you wouldn't have to worry about that. So you don't have to do it because yeah, you'll start fresh this week. So I will fix your dashboard to look like just this week's assignments. So I will fix that as soon as we are done. Because I thought that John told me there's one student that I missed that I got to get that done. Cool. Okay, so from the polling, guys, I'm getting that it would benefit everyone to do just a super fast run through on scientific notation. So that is what I'm going to do. I'll be very fast, I promise. So the first thing with scientific notation that we have to do is our goal when we're putting a number in scientific notation is to have a single digit whole number in front of the decimal, all the other numbers after the decimal, and then times 10 to the whatever number. This exponent, go back. The exponent refers to how many zeros you have, okay? So number of zeros. So if you have a super big number like 5,326.6, we don't need to wonder where the decimal is because it's already in the problem. And I need to move that decimal so that I only have one number right in front of it. So I'm going to count how many spaces. That's right. Very good. 1, 2, 3. So I moved it 3 spaces to the left. I leave all the numbers there. And since I moved it 3 spaces to the left, my exponent is a positive 3. If I moved it to the right, then I would have a negative exponent. Good. Okay, so let us put these numbers in scientific notation, one at a time, please. So for this first one, where is the decimal hiding? Where is that decimal? Yeah, at the end. Very good, you guys. Good. So then I need to move it. How many times am I going to move it so that it's where I need it? Good. How many times is that? 4. Good job. You guys are on. Wow. Oh, is that 5 or 4? Let's see. 1, 2, 3, 4. I got 4. So easy to get confused here. Sometimes I even write it a little bigger. 1, 2, 3, 4. Yeah, that is 4. So then we're going to write that as 8 times 10 to the 4. That's what we write it as. Very good. What about this guy here? That's another way of writing it. Very good. What about that one? Decimals at the end. And we're going to move it how many spaces? Yep, that's right. 8 times 10 to the 4th. Yeah, it's going to go right between the 4 and the 3. How many spaces did you move? What do you guys think? Yep, yeah, I like what I'm seeing right here and right here. And again, I'm bringing that up. Super awesome thing about writing on the screen is I can't tell who's writing what. So even if you're wrong, well, who cares? Nobody knows. It's all good. This is good too. Yeah, when we have other numbers in there, you got to leave all the numbers. And then we actually moved 10 different spaces. 1, 2, 3, 4. Oops, I counted weird. See, it's easy to do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, so it definitely would be that one. Yeah, good job. Good job, you guys. Next one. Okay, what if you saw it like that on a calculator? 3.1 e positive 8. What does that mean? Not error. A lot of people think error. Yeah. Somebody said E stood for exponent, right? And yeah, I like this here. E is how many zeros there are. Yeah, it could either be the 10 to the 8th, the exponent that you're thinking. It could tell you that the 8 is an exponent. Either way you guys are looking at it is absolutely correct. This is what I would put it as, 3.1 times 10 to the 8th. Very good. Or if you wrote it out, you would have a 3, a 1. Remember that there would be no decimal. But that's, well, yeah, that's the number of spaces. So maybe it's not that many zeros. So 1, 2, 3, 4, 5, 6, 7, 8. This is perfect. So it's actually 7 zeros. Yeah. So number of spaces. Very good. Very good. Nice job, guys. You're so smart. Smart students. Okay. So we kind of talked about this already. If we want to turn a number from scientific notation back into the number, where is the decimal hiding? Right here. And that's 6 times 10 to the 7th. Yep, right at the end of the 6. Yeah, we kind of already mentioned that. So then we take that decimal and move it how many spaces? 7. Yeah, you're right, Ayub. Very good. Let's not doodle too much right in front. That might be a little distracting. Okay. And that might have been pi. I don't even know. That's interesting. But yeah, we want to move it 7 different spaces. So 1, 2, 3, 4, 5, 6, 7. And then we would fill all of those in as zeros. Very good. How many spaces am I going to move the decimal over here? 3. Right. So I'm going to start with 8.43 and I'm going to move 3 spaces. 1, 2, 3. And I just have to fill in 1, 0. Very good. So we have 8430 is my number. Good. Good stuff, guys. See, we're getting through it quickly. All right. Now, what do you think we're going to do for this number? We have 9.5. What am I going to do? What does that -5 mean?
We're gonna go back 5.
Yeah, we're going to go backwards 5 toward the negative area. Think the negative side on the number line. Here's the number line. So we're going to go -5 in the negative direction. 1, 2, 3, 4, 5. No, you got to move the whole decimal point 5 places. Yeah, I love it when people do that because then I can just answer a direct question. That's very good. You're right about the number of zeros. Actually, I think you would need one more 0, but the
Drawing on
decimal
my thing.
travels with.
Drawing on my answer.
Somebody's drawing on your answer.
Yes.
Which one was yours, Annabelle?
The yellow one.
The yellow one, yeah. Yeah, we don't want to put that there, right? Because she's right, because she's drawing this one, and we wouldn't want that decimal there. Because when, oops, I cleared everything. I didn't mean to do that. Sorry, guys. So, yeah, we're going to take that decimal. It's almost like you stick your pencil right on it and move it. 1, 2, 3, 4, 5. Yes, this is perfect. Perfect, perfect. So we're going to have 1, 2, 3, 4 zeros in front of that. Good stuff, guys. Nice work. All right. Next page. Okay. So just to review, we're not going to do those because we got to do this, but just because we talked about it enough already. But when the number is greater than 10, so if you have a big, big number, your exponent is going to be positive. When you have a small number, so like this number here would have a negative exponent.
I don't think so.
Question? Okay. Any questions, just ask. Seriously, it's totally fine. I know we're reviewing, but good stuff. Yeah, and this one's good. This would be, for this one, someone did it. I will respond. That's awesome. So that's like you have the decimal after the 7, and you go 7 places to the left. 1, 2, 3, 4, 5, 6, 7. So you're going to fill in 6 zeros, which is what you had. Oh, wait, no, I think you had 5 zeros. I think you just needed one more to the other side. So right here, I would stick it. If I'm counting my zeros correct. Oh, that's okay. No worries. Thanks for putting it on there. It's helpful. It's better to see your guys' work. You don't want to see my boring writing the whole time. Okay, Now let's talk how you multiply with scientific notation. I'm going to tell you with this sweet calculator. Oh my gosh, it's just so helpful. If you're really struggling with this stuff, if you go to desmos.com/scientific, you can type these questions in exactly and it'll tell you, and the answer will be in scientific notation. It's beautiful. So if you're really struggling, go check that out. Type them in exactly, use parentheses. You'll see me refer to Desmos all the time because it's a very useful, yeah, it's a great website. But for the rules, all we're doing when you're multiplying with exponents, okay, you're going to multiply the actual numbers. So the only actual numbers we're multiplying are 2.5 and 3.4. And for me, I would honestly use a calculator because that's totally fine. 2.5 times 3.4 gives us 8.5. And then for the exponent part, you're definitely going to have a times 10. But since both of the bases are the same as a 10, you're just going to add those exponents. Whenever you're multiplying with exponents and the bases are the same, you add the exponents. So 4 plus 5 gives you 9. And we don't need to rewrite that at all because it's already got just one digit in front of that decimal. And that's what I wanted. So we're good. But again, if you're absolutely stuck, go check out Desmos. Super nice. Okay, guys, right here, let's multiply those numbers. What do you get when you multiply the numbers? 5 and 1. What's 5 times 1? 5. Right. Good. Not 4. It's 5. 5. You're thinking subtraction. That's okay. I get it. We're doing a lot of stuff today. Okay, so we have that. So we have our 5. Then we need to bring in a times 10 because we're in scientific notation here. And we're going to add those exponents. What do you get when you add those exponents? 9. Perfect. You're right. So our answer is 5 times 10 to the 9th. Right. And sometimes you might have to do a little bit of adjusting, but we don't have to do any of that because we already have just a single digit number. And this should say 9. Oh, that does say 9. My thing was blocking it. My bad. Very good. Okay. Sometimes when you multiply, you have to adjust because you'll get a 2-digit number, and you can't have 2-digit numbers in scientific notation. So first we're going to multiply our numbers, 6.1 times 7, and I'm going to use a calculator. You guys too. Maybe you'll get it before me. Though I doubt it because I'm amazing. I'm just kidding. You probably will. Okay, what'd you get? 6.1 times 7. I got 42.7. Is that what you guys got? Someone was going to write a 4, so someone must have got that. Yeah, that's what I got. So we're going to have to, Aiden got that too, good. We're going to have to adjust that, but for now, we'll just leave it there for now. So we'll bring in our times 10, and we're going to add those exponents. So 6 plus 8. What's 6 plus 8? 14. Yeah, you're right. 14. Now, here's the issue. Because we can't have a 2-digit number in front in scientific notation, I have to move that decimal, and I'm just going to move it one spot to make it right. 4.27. Oops, not the other 2. Where's my eraser? There it is. Yeah, we need it to say 4.27. No. Jen, what are you doing? Okay. And then it's going to be times 10. What do you guys think we would have to do then? If I moved it one more spot, we would add. Yeah, some of you guys are changing it to 15. Very good. We're going to add. So it would change to the 15. Good. And it's hard to remember if you add or subtract. I always think because this number, when you stretch it out, you're going to get a big number. So basically, you're just adding another 0 onto the end. That's what you're doing. I'll show you an example where we subtract. Okay, dividing is kind of the same way. So dividing, you're going to divide the numbers and subtract the exponents. So we'll do 4.2 divided by 1.4. So 4.2 divided by 1.4. What did you guys get? I got 3. Is that what you guys got? Someone got 3. Excellent. And now we're going to subtract those exponents. And we got to be careful because they're both negative. So we want to subtract the negative numbers. So -7 minus -4. And you can use a calculator for that, or we can remember what happens. Yeah, that's absolutely correct. Yay, good job. Remember, 2 minus minuses makes a double plus. Good. So you do end up with a -3. Very good. Good work, friends and neighbors. Good work. All right. Oof, that's all I have. Cool. So we're switching gears now. We're going to switch into our conversation for this week about square. No, didn't mean to do that. That didn't go well. Okay. Okay. Nope, not that. Sorry, guys. I have a wireless keyboard that I just put my hand on. Okay, bad keyboard. You go over there. Okay, so we're going to talk about squares and square roots. Okay. What would you guys say 3 squared is? What does it mean? What is it? Either answer. Yeah, it's 9, right? 3 squared, what does that mean you're doing? What are you doing to figure that out? 3 times 3. Perfect. 3 times 3 is 9. 3 squared is 9. What about -3 squared? What would that be? Also 9. Yup. -3 times -3 is also a positive 9. Therefore, if we were to do the opposite, okay, the opposite of squaring is square rooting. So if we took the square root of 9, technically it could be a 3 or a -3. Okay? Just because you can square a negative number to get a positive number, right? Yeah. Yes. But this is kind of the weird part, okay? Are you ready for this weirdness? The square root of -9, that is a non-real answer. We can't do that. Why? Why do you guys think that? Why am I saying that's a non-real answer? So you can take the square root of 9 and get 3 or -3, but you can't do the square root of -9. Has Jen gone crazy? You can say
3
yes.
doesn't equal 9.
Say it again.
Because 9 can't equal 3.
9 can't equal 3. Well, remember,
Well,
when you're square rooting, you're figuring out what was multiplied by itself to get that original number.
yeah. And also that it can't be -3 because -3 is the square root of 9.
Right. You're right. Yeah, and I like what someone's writing on here. -3 times -3 is 9. 3 times 3 is 9. So and when you square a number, those numbers have to be the same, right? -3 times 3 is how you get a -9. Yeah, that's right. And is this really squaring 3? No, it's not. Yeah, because you're not multiplying by the same number. Very good. Good job, guys. So you can't square root a negative number. But what about this? What is that saying? It's kind of weird. I'm throwing too much crazy at you. I know.
Negative square root of 9.
Yes, you're right. Very good. That's read as the negative square root of 9. Yeah. So that one you can do because that's saying first take the square root of 9, then make it a negative. It's crazy. I know. Too much. What? I just highlighted the whole conversation. Why did I do that? Okay. Don't get it. What doesn't make sense? Is it just... Yeah, I know. It's okay to be confused. It's a little crazy. Everything. Okay. So does it make sense right here? I know we went for a loop right here. That's where we kind of went off the beaten path here. What about this? Does this make sense? How if you square 3, you get 9. And if you square -3, you also get 9. Okay, good. Very good. See, that's all I need, right? What about down here? How the square root of 9, so if we take the square root is a button on your calculator, really. It's like figuring out what was squared to give you that 9. Does it make sense that it could be 3 or -3? Does that make sense? Is there a tiny yes? Yes, makes sense. Okay, good. Well, then we'll just start with that because that is all I need for now. Don't worry, we'll build in more crazy as we go along. You like my evil laugh? Okay, so everybody in your notebooks, let's write down our perfect squares. These are so, and if you know them, you don't have to write it down. But if you don't know them, this will help us with simplest radical form, okay? Perfect squares, what I mean by that is what's 2 squared? Oops, I heard someone say it.
4.
4, very good. 2 squared is 4. What about 1 squared?
2.
You'd think so. You totally would. It's just 1. Yeah, that's one of those weirdo ones. Everybody, yeah. Very good. So let's keep going. We got to get 3 squared on there, and you guys can just write it on there for
16.
me. 4 squared is 16. You got it.
9, 16, 20, no, 10, 12.
And be careful, guys. Look what's happening here. We see 10 and 12. What are people doing when they do that?
They're multiplying 2 and 6, but
Yeah,
it's actually 36.
right. That's a very common thing to do. Everybody does that. That's why we do this. Yeah, that's very common. Common mistake. Are we going too fast? Sorry. Don't mean to go to, please tell us. Yeah, what we're doing is we're just squaring the number. We're multiplying it by itself. So 5 times itself is 25. 6 times itself is 36. And these are called the perfect squares because there's no decimals involved, and we're going to use them to help us simplify other radicals. Right. 2 squared is the same as 2 times 2. That's right. 100 is 1, right? Yeah, you're right. That would be what 10 squared is. Very good. What about 9 squared?
18. No.
You're doing what everybody does. And then
81.
81. You caught yourself, Annabelle. I saw that. See, I love the cameras on. She was like 18. No, wait. That was awesome. And then 11 squared, 12 squared, and 13 squared. These are the ones that I would like try and have in your brain. This one, I'm going to do a little fixie here. Just a little one. This one's 144. This one's 169. This one's 121. So this is a list that I would get down somewhere because it really helps you when you put numbers in simplest radical form, which is what we're doing today. And kind of the opposite of that, that would mean that the square root of 4 is 2. Square root of 9 is 3. Either way you have that down really helps. Oops. It's 25. Yeah, either way you choose to write them down would be great. Yeah, 121 does not seem like that's what it would be. That is. That's a common one. Yeah, so take a second and get those written down because we're going to use those to make simplest radical form. I'm laying on my bed so I can stretch out my back. Yeah. I was so convinced my daughter would be calling me saying, come get me, but nope. It's good. Okay, you guys got that written? Do we have it? Those who are taking it down? Can I switch it? No. Okay, good. No problem. Here, I'll put my poll up there asking if we're good to rock and roll. So once you are ready, once you have written it down, please select yes. And if you've already selected no, that's fine. Just change your answer to yes once you are ready. You look so warm and snuggly there, Annabelle. Is that a blanket or a sweater?
Blanket.
Nice. Nice. Okay. My person in red says I can go. What about my person who answered no on the poll? It was me. Okay, cool. Thanks for the communication, you guys. I love that. That's super helpful. And I say it sounds ridiculous, but seriously, super helpful. Okay, so first thing I want to bring up is that all of these square roots you can evaluate right in Desmos. Seriously. So easy to put in there. It just works. I'm going to clear all that stuff off. Okay. When you're taking the square root of a number like 121, this looks a little suspicious, right? What is this 121? Well, 12,000. It makes us think about 11, right? Yeah, but the way the zeros work with the square roots, it's a little weird. So in your head, I would think, okay, that just means 11, and then I would double check your thinking in a calculator. So in a calculator, I did it, and we got 110. Hello, Annabelle's kitty. Hello. Now,
This is Harley.
Harley. Hi, Harley.
Okay.
Now, if you're taking the square root of a fraction, you can type it into Desmos just like that, but what does it mean? What does the square root of 289 over 324 mean? Can I break it up? Can I say the square root of 289 over the square root of 324? As Michael Scott would say, abso-fruitly, right? Sure can. Abso-fruitly.
Love The Office.
Love The Office. Yay! Office. Oh, I love The Office.
Grandma.
So, yes, you take it, the square root of 289, you do get 17, and the square root of 324, you do get 18. So 17 over 8. And you would leave that as a fraction. Yes, good stuff. Any questions so far?
Nope.
I think someone was asking a question here, but I missed it / half erased it. Sorry. Let me know. What is this decimal? What is this? No, you'd think so. You'd think so. I'm wondering if you typed it in interestingly. I'm wondering if that happens, because look at how this is with the 169. What if I took the decimal out of there? That's one of our perfect squares. What's the square root of 169? $13. Yeah, you're right. Totally is 13. So when you do it with a decimal, and I always double check this pattern, but the decimal, oh, you're not slow. No way. Slow is good in math, more detail oriented. You're good. Okay. But when we take the square root of that, we would put the decimal in exactly the same spot, I believe. But we're going to double check this, because this is pure with patterns that these numbers make. Okay, so I'm going to hit 1.69 and then the square root. Yeah, and you do get 1.3. Okay, so just use that calculator. It totally helps. Yeah, and you guys did that down here. If we took the square root of -9, you actually take the square root of 9, which is 3, and then this tells it to make a negative. That's it. Now it's tricky because this is also correct, because technically with the square root of 9, you could get a -3. And then 2 negatives would make a positive. I'm going to tell you, if they only ask for one answer in Math Excel, it's going to be this one. They're going to not have you worry about the negative case. But if it says give 2 answers, then that would be it.
Who's drawing on my turtle? Who just drew all over my turtle?
Your turtle?
Yeah, right
Oh, there's a turtle. It's my chat was blocking it. Don't draw on the turtle. That's a cute turtle. And the turtle is there provided that we know what we're doing. Then Jen has no problem.
here. Hey,
Math Papa. Is that another website?
hey. I just deleted my turtle. I'm gonna draw another turtle.
Okay. Okay, guys. Now, this is a really good example right here.
Thank you.
Right here, guys. Everybody look what's happening right now.
Yeah.
What is all of this delightfulness doing to the class? Could it be potentially pulling away from instruction a little bit?
Being a distraction.
Yeah, little bit. So this loveliness is totally fine. I don't mind a little doodle here and there, but when we start messing with doodles and covering and then commenting, that's when Jen has to be mean and either turn on the little name that pops up so I can see who's doing it, or turn off annotating altogether.
Okay, my turtle's done.
The turtle was epic. Totally worthy turtle. I'm serious. He's staying there.
That was not good.
Okay. All right. Oh, this looks like a slick looking kitty cat over here. All right. Anyway. Oh, he's a super kitty cat. Guys, we're in the presence of greatness. This is awesome. I know, right? Is that a good comment or a bad one?
Great, now even the teacher's distracted.
I am highly distracted.
I fell asleep in mine.
Hey, that's better, right? I'd rather not lose people to sleeping. That wouldn't be fun. Yeah, and hello, by the way. Hello. Good to meet you. Okay.
It's my mom.
All right. Let's talk about this guy right here. This one. And we're almost done. We're almost done. We're so close. This one right here. The square root of 21 squared. What do you guys think that would be? You can type it into a calculator. What do you think? Yeah, look at this one. I like that. Why would it just be 21? What happens when you square root something that is squared? Yeah, whenever you have a square root inside of a square inside of a square root, what happens? Because, right? Just because. I like that. They cancel. Yes, even better. Someone was writing that. It just cancels out. You're right. Whenever you have the square root of something squared, it cancels out. Mathematically, what would happen is you would first take 21 and square it, and then take the square root. And that's just very redundant. We don't need to do that. What about down here? 7, and then the square root of 225. What would I do first there? So someone is saying it would be 105. What do we do first?
But
I have a feeling you're gonna get sent home. So. Probably see
What
you
do you
early.
think? Callie says 105 too. What do you think, Annabelle? What would it be?
105.
Think it would be 105? Someone says 115.5. What would we do first here? What's really going on? Yeah, someone's putting Someone's putting a sign right in the middle there. We would focus on, we would divide and conquer. Yeah, I love that. Divide and conquer. Whoa, not a fan of the red all over. Please don't do that. Okay, that's not very kind. Okay, so we would first take the square root of that 225. We would first take the square root of the 225, and then we would multiply it by that 7. That's where everybody's getting 105 from. So what's the square root of 225? Is it really 115.5? Let's see. Let me see. Oh, I'm wondering if you're dividing by 2 instead. Yep, I think what you're doing there is dividing by 2. Remember, to do it on a calculator, you have to hit 225 and then hit the square root button. The square root button on my iPhone calculator shows up right on the side over here. I think it's like right there. Okay, but once you hit 225 and then hit the square root button, you get 15. When I divided by 2, I got 112.5. So maybe that's where the 0.5 is coming in. So we take the square root, then we multiply by 7, and that's where we do get 105. Good. So things we have to remember with square roots. It's a button on the calculator. Okay. We were figuring out what was squared to give us 225. So 15 was squared to give us 225. You always take care of the square roots first and then multiply it by what's in front of it after. Now we're going to talk about something super important here. Oh, not yet. We have to talk about this, which is good, but still good. What about that first one? This one. Ah, not that. This one right here. Can I do that one?
No.
Nope, can't do it. That would give you a non-real answer. Okay, and there are imaginary numbers. Isn't that crazy? But there are. They're mainly used as measures of like conductivity of electricity and stuff like that. They're very specific purpose, but we would just say for now, when we're not really using imaginary numbers, we would say non-real answer. So
Imaginary.
it would be imaginary. It sure would. So we would just say non-real result right now. Now I got to simplify this radical. Now for this one, they don't want a decimal. Okay, so guys, make sure you're listening, because when it says simplify the radical, that means no decimals. So we're going to do what we knew before. We're going to take the square root of the top and the bottom. Which one can I take the square root of real nicely? The top or the bottom? Yeah, we don't want any decimals. You're not wrong, but that's not considered simplified because it's rounded, and anything rounded in math is not accurate. No, that's okay. I'm glad you put it on there. I really am, because many people will do it. Yeah, very good. This is excellent. The top, since that gives us a decimal and there's no way to simplify it, we leave it there. We just leave it alone. And since the bottom simplifies real nicely to 2, that would be our final answer. We would just leave it as the radical 17. Another way for a radical, another word for it is square root. That's another word for it. Radical. It's radical, man. No. No, Jen. No. Okay. So I believe we have just one more page. Yes. Okay, so we want to see if this is true or false. The answer, the square root of 157, would be between 12 and 13. So some people say yes, some people say false. Let's check that. There's 2 ways you could do this. You could take the square root of 157. You could do that. That would give you the right answer. 157. Oh, the square root of 157 is 12.52. So it is. Yay. But for your homework, I know for a fact that you're going to be asked, they're going to say, what two numbers is the square root of 157 between? Okay, you could either find it and then list the two numbers it'd be around, or think of those perfect squares. Okay, which one of our perfect squares would be around 157? So, I mean, 9 squared was 81, 10 squared was 100, 11 squared was 121, 12 squared is 144, 13 squared was 169. What do you guys think?
144.
Yeah, 144 and 169. So 12 is the same as the square root of 144. And 13 is the same as the square root of 169. 157 falls in between there. So that means that the answer to the square root would be between 12 and 13. Cool. Very last thing I have to mention to you fine people today, very last thing is simplifying a radical expression. Yeah, good job doing this. If I tried to do this in a calculator, I would get 5.19 blah, blah, blah. Not accurate. We don't like that. We want to simplify. And we're going to use those perfect squares. So I want to use the perfect squares to rewrite 27 as two numbers that multiply to be 27, and one of those numbers has to be a perfect square. So what are my factors of 27? What times what gives me 27? Yeah, 9 times 3, very good. 9 times 3 gives me 27. So which one of those can I take the square root of real nicely? The 9. Yeah, I can take the square root of the 9 real nicely. So I'm going to do that, and I'm going to yank it out of the radical. And whatever I could not take the square root of real nicely just stays in that radical. So my answer would be 3 radical 3. Good question. You don't need to have the dot in there. Not wrong if you have it, but you don't need it. Great work. Do you guys have any questions? I'm curious to see what this is. Is this another way to get $18 times 22? I like the house being drawn over the 3. I'm confused about that question there. Yeah, if you think of it, oh, no, you're not distracting. I just didn't know if you had a question. That's what I wanted to make sure. That's what I care about. Okay, last thing here, guys. Let's do this last one. Square root of 720. Oof, that's a big one. Let's think about let's think about our perfect squares. So we have 4, 9, 16, 25, 36. What's next? 7 squared, 49. 8 squared, 64. 9 squared, 81. We've got 100, 121, 144, 169. Okay, so I want to pick two numbers that multiply to be 720, and one of those numbers has to be one of these. So that means I'm going to take my calculator and I'm going to go, because I have no idea right now. No way, man. So I would go 720 divided by, I'm going to pick a big number, 64. Nope, doesn't work. So 64 is out. 720 divided by 36. Ooh, that worked, but that might not be the biggest one. So let's try bigger. 144, does that work? 720 divided by 144. Yay, you're right. Good job. That's definitely going to be the biggest. So 144 times what gives us 720? 5, yeah. And the only one that you can take the square root of is the 144. So what would our answer look like? What do you guys think? The 144, let's say they took the square root of it and yanked it out, but that 5 was still left over. Oops.
144 times 5 equals 720.
Yep, you would say that, but let's finish the square root there, because that's what you would write. That is true, but we can take the square root of this 144, right? What would that be if you took the square root of that 144? And if you don't remember the perfect squares, that's okay. Calculator, totally fine. What do you think? What's the square root of that 144? 12. Yeah, 12. Square root of 144 is 12. And that is what goes on the outside there. So our final answer would be 12, because we took the square root of that one, times the square root of 5. That's another way to represent square root of 720. So my suggestion for you on your notebook is to have these perfect squares. Start kind of going over them, getting used to them. Okay, 4 squared is 16, 5 squared is 25, all that good stuff. But that's all I have for you, lovely people. Ooh, we're a little bit after 12:30. My bad. I will be careful to watch that next time. Actually, it'll probably be early next week because we won't have anything to review unless there are questions. So let me know if you need anything. Anthony, I'll make sure that you have all the correct logins today, and I'll update your to-do list. So you guys are free to go. Have a great day. Thank you for coming. It is
Bye.
bye. It's always